We are graphing exponential functions. Yesterday, we just looked at growth functions. Today, we'll do a few examples of decay functions, and then you will continue to work on your practice that you started yesterday. So if you missed yesterday, I did record it. I always record my lessons and link them in the slides that are always in school review. So every single day that there's school, there is a slideshow. So anytime you're absent, look at that slideshow. It tells you everything. It has the goals for today. It has the video lessons. It has what the assignment is, where to access it, where to upload it, what to do, and then any quizzes that are coming up. Now, most of you also have me for algebra. There might be like one or two people that don't, but either way, the other algebra teachers follow a similar deadline assessment list. Just, refer back to them for when the assessments are. But otherwise, like sometimes they change, sometimes they get pushed back, sometimes they get moved up. So always just refer to the slide in Schoology, and that'll give you the most up-to-date information. All right, so let's look at the note sheet first, because again, we only did growth yesterday, not decay. So, and also if you missed yesterday for any reason and you just want the notes, they're also there. So like there's a math lab Schoology that's different from your algebra Schoology, even though it looks mostly the same. Like here's the notes from the other day. Here's the notes from yesterday. So if you need all this, or we go too fast, or you go to the restroom or something, it's there. And always hang on to your notes, because we do also do binder checks also for math lab. So it's supposed to be an easy way to get some good grades in the assessment category that aren't just based on accuracy. Because when everything's based on accuracy, it's hard. Like assessments are worth 80% of your grade. That's not easy, but hopefully by putting in some binder checks and rewarding you for taking notes, which is an important life skill, those grades aren't as affected by like one factor. All right. So look at number 2 on your note sheet, this one. If they want me to graph this exponential function, and I know it's an exponential function because it's in the form y equals a times b to the x, what do I do first? They want me to graph it. Step 1 is to make a table of values. So that's in XY table. And the x's we get to pick. Now look at what we have here. The x-axis goes from -10 to +10. So you're gonna basically just pick numbers that you think the graph will be around. If you ever are not sure, starting with like -2 to +2 usually works. So the x's are the independent variable. We have to pick what those are. The y depend on the x, and you get that y value how? So plugging in the x. So like if my first x is -2, plug it in for x on the given equation, and that'll give you the y value. That's basically how it is for any type of function, whether it's linear, whether it's this, whether it's quadratic, which you'll get to later this year. Just make a table, pick some x values, plug them in. And plugging them in, don't make it hard on yourself. Use a calculator. I don't know what 1/4 to the -2 power is, and I've been teaching the same class and using the same materials for like 4 years now. So pull up the calculator and do 1/4 in parentheses, just like how it is on your paper. exponent button is this one, A to the B, and then you type in -2. So 1/4 to the -2 power is 16. Fill in the rest yourself. And if you use Desmos, it's really easy because all you have to do is change the exponent. You don't even have to type it a bunch of times. But whatever calculator you plan to use on your test, use that. Highly recommend like your own handheld graphing calculator. So fill in the rest of the table real quick. Table 2, what is the y when x is -1? So really this is a test on if you know how to use a calculator. What is the y when x is -1 for this number 2 problem? When x is -1. Question. Okay, it's fine. It's 4. We'll see, actually. I don't know. I'm not for now. Yes, it is 4. Just making sure we all know how to use a calculator. I know some of you do and know how to very well. I need everyone to know. That's why I assigned the tables for that. Even if you only do that one problem today, at least you know how to do that one problem. Table 3, what is the y when x is 0? 1. Good. You might have not even needed a calculator for that because anything to the 0 power is 1. Table 4, what is the y when x is 1? 0.25, let's see. Yes. And then table 5, what's the y when x is 2? Okay, good. So an even smaller decimal, and depending on where you round it, at least give it 2 decimal points. Yes? 16. All right, so that's using a calculator. You need to know how to use a calculator for this unit. There's no way around it. There's no way you know all that. Okay. Now graph it. So find -2 on your x-axis. Find 16 on your y-axis. That's off the graph. All right, each of these have 10. So this one you just won't be able to graph because you have to. But we can graph -1 up 4. So find -1 on the x, 4 on the y, that's where it goes. Graph 0, 1. Graph 1.25 and 2.06. All right, what you'll notice with exponential functions is the graphs either look something like this, where they increase, or something like that, where they decrease. Maybe a little less like an L, more like a J, but it's not just like a straight line in one. So is this one going to be growth or decay? Decay, because is it increasing from left to right or decreasing? Good. Also, usually we connect the dots to show like what it looks like on your calculator, for example. So this graph will look something like that. So it's decreasing from left to right, it's decay. Also, you could tell by looking at the formula because the number attached to x, is it bigger or smaller than 1? Anytime it's smaller than 1, it's going to be decay. Without even graphing it, that's what it should be. So, and that's in our vocab here from yesterday. But if you weren't here yesterday, that's online. All right, so then now the domain. That's a semester 1 skill. So if it sounds foreign to you, it's basically all the what in a function. All the x's in the function. So table 6, does this graph look like it goes infinitely to the right? Does it look like it goes infinitely to the left? So my answer for domain would be good. And yesterday we said that if it goes infinitely left and right, because again, the domain is all the x's, that it'll be all real numbers, and since it either looks like growth or decay, it'll be all real numbers for the domain in this whole unit. Unless they're saying like no negative stuff. All right, the range is referring to all the what in a function, table 7. Range is all the what in a function. The y's, good. So then table 8, does it look like this graph goes infinitely upward? Yes, it does. Does it look like it goes infinitely downward? So when it doesn't go infinitely in one way, then you put, for range, we're gonna put y because it's referring to the y's. We're gonna put an inequality symbol, but I usually say that for the end. And you're gonna basically say where the y's stop at. So where does it look like the y's stop? Like, do the y's stop at 2? No, because we have stuff under the 2. So where does it look like they stop? Well, 4 is up here. So it's still stuff under, so that wouldn't be it. Yes, it would be 0. Now, would we say that the y values are greater than 0 on this line or less than 0? Greater, because like here's 1, 2, 3, 4, all these y values are greater than 0. Do they touch the 0 exactly? No. It might look that way on the graph that we drew, but if you look at the table, it doesn't actually touch the 0. In fact, if I keep increasing the exponent, like make it to the 6th power instead, it still doesn't touch the 0. It just keeps getting closer and closer until I still never touch the 0. Like I zoom in. It's not touching the 0. It looks like it is from far away, but it's not. Questions about that? So don't put the little line underneath. Now, table 1, what is my y-intercept for this? Or not table 1, sorry, table 2. What is the y-intercept for this graph? 0 on the y is there. So what is it? Good. And if we write it as a coordinate, it's 0, 1. So yeah, it touches the 1 on the y-axis. So that's my y-intercept. Also, you can see it in your table. Your y is whenever, or your y-intercept is whenever x is 0. Now, asymptote, that's a new word. We haven't even talked about it in algebra yet. What does it mean? Table 3. Oh, so you're telling me what it is. So it is y equals 0. But what does it mean? A line that the graph gets close to but never touches. So just like the range, I feel like these are really similar. Only difference is when you're defining the asymptote, it's supposed to be a line, so not an inequality. So you put an equal sign. All right, but it's the number that the y's get close to, but never actually touch. Like I showed you, it never actually touches 0, just gets close to it. Questions there? All right, we'll do one more from the notes. I'll actually have you, or maybe we'll do it from the practice, so that way you get, a problem done on your practice. So 4, I think, is easy. So I'll let you do that one on your own. Let's look at number 9. So this will be the you try. It's not on your notes, it's on your practice, so that way we just get at least 1 year practice problems done. Just to kind of get you started, what's the first step in graphing these? Make a table. The x's, you get to pick what they are going to be, but if you don't know what they should be, what's a good place to start? Good, -2 to +2 is usually a good place to start. Sometimes you have to add a few more in case the graph is more like this way, instead of like in the center. But either way is fine. So I would start there. How do you find the y's? Good, so take each x, plug it into the exponent, because that's where the x is, the equation, and then write down what your calculator says. So you should be using a calculator, it should not be using these instead. Table, I don't remember where we left off, so I'll just start with table 3. Table 3. What is the y when x is -2? Okay, let's see. So type it in to your calculator, because there's no way, I highly doubt any of you can do that in your head. And it's 4.25. Is that what you said? Yeah. Okay. So good. Table 4, what is the y when x is -1? 3.5, good. Table 5, what is the y when x is 0? I see why you got that, but it's not. Or is it? Am I lying? Let me check. Yeah, because anything to the 0 power is 1, but then we still have that +2 that's in the given equation. So it's actually 3 for that one. So not a problem, just fix it. If you notice that your numbers are like decreasing in the y and suddenly they increase again, there's probably something wrong. So always go back and check. But then table 6, what is the y when x is 1? Good. For rounding though, it should actually be 2.67. I mean, it won't really affect you for the graphing at all, but if you were typing in an answer on your test, just know that wherever you're rounding to, look to the right, since that is between 5 and 9, you round up. So 2.67. Table 7. What is the y when x is 2? Good. 2.44. Now, if you graphed it already, good job. The -2 up 4.25. 1, 2, 3, 4, and then up a little over that, be there. -1 up 3.5. Here somewhere. 1, 2, 3.5. 0 up 3. 1 up 2.67. And 2 up 2.4-ish. Now, when it looks like this, you might want to add a few more points if you want. I still think you can see that it has that same shape we talked about earlier. And would this be growth or decay, table 8? Decay, because it's decreasing from left to right. Table 2, what would my domain be? Not 2, but all real numbers for the domain, yes. Because domain refers to all the what? All the x's in a function. So x-axis goes from left to right. So look from left to right. It does go infinitely left. It does go infinitely right. So all real numbers when it's like that. Infinite in both directions. Now for the range, table 3, what would it be? Y greater than 2. Anyone disagree? All right, good. So it does go infinitely up, does not go infinitely down. It looks like it stopped. From looking at the graph, it looks like it stops around the 2. If you really want to know for sure, you could like test the values in the same equation we already plugged stuff into. Like if the x is now 10, even like a big jump, it's still not going under the 2. And it's still not touching the 2. It's just right above it. If it's to the 100, oh, I guess it's so big that it tells me it's 2, but it's really not. Like it'll keep being closer to 2, but it will not be 2 exactly. So that's telling you that on this graph, all the y values are greater than 2. Good there. Then y-intercept, table 4, what's my y-intercept? Three is correct. Or 0, 3 if you write it as a coordinate. So y-intercept is whenever x is 0. And where it touches on your y-axis. Asymptotes, table 5. If you understand range, then understand that the asymptote is really similar to the range. What's the only difference? Can I write it? Here, the range and the asymptote. Y equals, for this one, it's 2. But it looks just like whatever your range is for that problem. Just instead of an inequality, put an equal. That's it. All right, because it's supposed to be the line that it gets close to but never touches. So lines we use equal signs. Right? Questions? Good. All right, and as you can see, the y's get close to 2, but they never actually touch the 2. So that's why that's the asymptote. It could be slightly different for whatever problem you're looking at, but yeah. So I think that's enough notes unless you have questions. What you'll work on for the rest of class is your practice, and then we'll probably have to give you some time tomorrow too. So now you should be able to do all the problems. So if you have questions, let me know, work through them with your group. If the printer was working, I would have the key up on the wall, but it's not. So I'll just have to show you the key once we're all done. Question? Yes. All right, now would be